I'm here today as a openSUSE community member, and for the last 3 years I've been tinkering around with a SPARC port for openSUSE, and today I will present the current status and how I actually got to this port. So the SPARC 9 version 9 ISA was specified in 1994. It is a 64-bit ISA, which means you have 64-bit registers and also instructions to do computations on the 64-bit values. It's still a RISC machinery, and the instructions are relatively short with only 32 bits each, which means if you have constants to load into registers, you need multiple instructions, for example. It's the same with PowerPC. Prominent manufacturers of SPARC hardware include Sun, formerly Sun, now Oracle, and Fujitsu. They both have a cross-licensing, cross-branding agreement, so you will find machines that are colored both black and silvery red. There are also emulators available. There's QEMU, which has a SPARC 64 emulation mode. However, unfortunately, this doesn't seem to boot the latest kernel, for example, from a Debian version 6 ISO. So that doesn't quite work. The systems from Sun and Fujitsu also come with a remote console for diagnostics and management. It's a separate chip which runs VxWorks, I think, and later Linux on a PPC chip. And I wanted to do a short demo of how this actually looks. Okay, so this is, for example, the management console of a TE1000 machine, where you can inspect environmental parameters and memory faults and so on. This is on the separate chip, and if you start the console, you get the Open Boot firmware prompt, which you can also find on PPC machines. So there's a lot of common properties between these two architectures. We will hear about power in the next session, so that is that. And this is actually how the Open Boot prompt looks. It can do simple mathematics, for example. That's 5 and 5 equals 10. It's 0, 8 in hex. So kind of interesting to see that, what these things can do. So this conference is about bootstrapping, and of course I had to bootstrap in a way the SPARC port for openSUSE. And what we in the end want to have is RPM packages that we can install with Zipper, or preferably for a start with plain RPM. There's many ways to get there. You can do a cross-compile or a native compile, and even there's some differences on how you can actually go there. When you try to cross-compile, there are sort of pitfalls that we have. One that I originally ran into is that you just don't have the headers from the Linux kernel installed in user include. That has now been fixed in at least openSUSE. And a different problem is that you cannot run just build executables. This is very important if you have if these just build executables are used to generate further sources to be compiled. This is the example, for example, in Weston, this is the case, and also, I think, in Xorg, which generates its protocol descriptions from XML files. And because of that, you just couldn't cross-compile these. But you can do that for the toolchain, bin utils, and GCC. but it quickly gets very hairy if you when you try to compile glibc, I always ran into some strange error, and I just thought I'll leave that to the experts that do cross-compiling when there's new and a really new architecture coming out, and they can do that. Programs that are called by configure.ac or whatever else you like also only reflect the host status and not the actual target architecture. So there's always problems. The most often seen problem is that people call uname-m or something, and that always goes wrong. It also goes wrong on SPARC itself, which is sad to see. The problem lies within the source packages, of course, because you shouldn't be calling uname. And that's why we should aim for a native compilation. Even openSUSE, the openSUSE ARM subproject, does use native-looking compilation using QEMU as an emulator. So go native if you can, also because it's faster for most of the speedier chips out there. ARM is a low-power hardware, so maybe QEMU is faster if you run it on a high-end x86, but in case not anymore? Not anymore. That's great. So you know, native is very good. However, so the last SPARC release then SUSE Linux made was version 7.3, to the best of my knowledge. This had a 2.4 kernel and a very old GCC that if you tried to compile a recent GCC with this very old one, you immediately ran into errors because it expected some definitions from GCC 3, I believe. It has been a few years that I actually tried to native cross-compile from 2.4 to a 2.6 system. That hasn't gone very well. So a modern toolchain is very highly desirable, even if it means that you have to be unfaithful for a while. So I went through a different Linux distribution. There are a handful to choose from. For example, Debian has a SPARC port. I believe Gentoo does as well. And Fedora also had one sort of in the backyard like my project is now, which is what I eventually picked because it has RPM available. Yeah, it's reasonably close to the SUSE products with RPM. I could have also chosen Debian or Gentoo as a base and start compiling RPM itself there, because it wouldn't an RPM program binary compiled on a Debian or Gentoo would have been an option because RPM isn't used as the normal package management, so it would not interfere. In case of Aurora Linux, or it's now integrated into Fedora halfway, the obstacles are that you have conflicting macro definitions or SUSE-specific macros that the Fedora RPM program doesn't know about. And that's probably one case where using a different distribution would have been an option. I chose to go with Fedora anyway, and that worked reasonably well. You start by producing RPMs from the Fedora environment. It needs a bit of tinkering because of conflicting files, and so you often need to force your way around, so to speak. And so when you have your first RPM produced in the original Fedora system, you start building up a chia root image in a separate directory, also with Fedora, and then start replacing packages one by one. Usually you start with, I think, file system and AAA_base, and progressively continue through gzip, core utils, and these small packages to glibc and the compiler itself. And you repeat this process inside the change root as well until you have a subfile system made only of SUSE RPM packages. From there, you want to reasonably quickly get a build server's instance running, because the automated package build and rebuild that the build service offers over plain RPM build is golden, so to speak. Many packages compile without any changes whatsoever, which means I was in fact able to compile, I think, 2,000 or 3,000 packages of factory without much effort in a handful of weeks, depending on the speed of the CPU. For the toolchain itself takes the most time, because glibc and GCC are rather big packages, just like the Linux kernel, and they have a tendency to compile, fail sometimes, or the test suite runs afoul of one test, and then you don't know what to do. You try around and have to wait again until the entire package completes again. And a kernel compile on the T1 CPU takes about 52 minutes in, I think it was all mod config, or the standard SUSE config, so the speed is not that stellar. It's an old machine that I have. The model was produced 2005. So, well, I had time, so I did it anyway, and it succeeded. The modifications I had to make to the build service code, that is the build script and the actual web interface and so on, are already upstreamed by me within the last years. In building, we will produce two targets. One is called SPARC v9 and the other is SPARC 64. As I said before, the SPARC v9 ISA is a 64-bit architecture. However, because these CPUs are not as efficient as x86 to compute 64-bit results, people prefer to use a 32-bit user space environment for reduced pointer sizes, memory footprint, and so on and so on. And SPARC v9 is the RPM target that I use for these 32-bit packages, in fact. Other distributions do the same. Debian, for example, you will also see they have mostly, if not all, 32-bit ELF images programs in the distribution, perhaps save for the kernel and a few extra programs. And it's once again the same for PowerPC, where you also have mainly a 32-bit user space. I mean the old PowerPC, for example, that you will also find in the Apple Xserve G5 machine, which has a PPC 970. Also almost more than half a decade old by now, but that's the things that people can actually get off eBay and not lose all their savings. So SPARC 64 is the other target type. This is for 64-bit ELF programs. A few programs really need this type. For example, the kernel itself. Of course, you want to address more than 4 gigabytes of RAM. Not only that, but there's also a hardware difference here. Other programs that need to be 64-bit are, for example, GDB and strace, everything that uses ptrace, because for some reason you need a 64-bit watching program to actually watch a 64-bit program. And I call this a duality. You can actually have a purely 32-bit user space or a purely 64-bit user space, or you can actually mix both of them. So if you, for example, install gcc-472.sparkv9.rpm, your GCC defaults to producing ELF32 binaries, and you can install an extra package called gcc-64bit that makes available the 64-bit option. You can also turn it around. Maybe I could show a demo of that soon. However, zip doesn't actually cope with this duality yet. Zypper always looks at the uname, I believe. There may be a config option by now to tune it. I don't know. And it will always pick these Spock 64 packages, which may not be what the user actually expects. Yes? Yep. So we're told the solver always chooses the best architecture, but as you know, there is no best. You pick the one that you like most. He says it's configurable. That's good. This also was kind of irritating because on PowerPC you basically have the same issue, and the openSUSE PPC release installs 32-bit packages by default. And also Zypper does that as well, so it gets it right there. But I believe your /PPC is a 64-bit user space, is it not? The one for Z systems. No, not that one. And yeah, and you run them with 64-bit packages in user space? Yeah. So it seems solved for PPC. It isn't yet the case for SPARC. We'll have to. I will ask on the mailing list as you suggest. Right, where was I? I have a handful of issues, some minor, some more pressing. For example, GCC doesn't produce actual V9 instructions for the 32-bit target, which I don't know why it's not doing that. I filed a bug report for that as well. So far, it doesn't seem like anybody has replied, which is a bit sad. But nevertheless, we can produce 32-bit packages. They are called V8+, so it's like last decade, but it works. Everybody else also produces V8+ packages, so I think I'm fine on that occasion. There are certain limitations of the PROM interface, this little thing. For example, it can only, when it downloads packages, when it downloads a kernel from the network to boot it, there's a limitation of 10 megabytes. On the Apple PPC, I believe it's somewhere same in the ballpark, maybe even less, maybe a little more. Even on P-Series. And this is very problematic because the SUSE PPC installer is like more than 30 megabytes in size, and you just can't boot it over network, which is sad. Even more so because the T1000, the one that I have, it doesn't have any CD-ROM drive, nor does it have any USB. So I basically have to prepare a hard disk before inserting this into a machine, and that makes testing the installer, should I ever get to it. I don't have a Kiwi image yet. Makes testing very difficult, least to say. And sometimes I also have a very, very strange compile failure that only happens. This is a current issue actually. It only happens if GCC is run under glibc 216, and it happens randomly, and it's not a memory error because I would see that in the diagnostics. It's ECC memory and all that. And it also only happens if I compile using the setup glibc itself or GCC itself. If I stress test the kernel compile, this doesn't happen, and I haven't yet figured out why that is. An extra problem is the latency with the build service. As you all know, it's written in Perl. It also embeds the zip solver, which is in C++, but there's still a lot of Perl code in there, and that executes even more slowly than on x86. And an additional problem is the network latency. At first, I made package links, _link to factory using build service remote linkage, And that meant on every cold start of the scheduler, all the architectures that I had started the scheduler for would download or would request more than 8,000 metadata requests to the upstream build server that is located in Nuremberg. And so I had about a cold start delay of 30 minutes, 45 minutes for merely 8,000 packages. That wasn't going very well. So eventually I replaced everything by importing whole source packages. And that went sort of away with that. So here's a little, let me see. Okay, so the last successful build I have is an 11.3 image. There should be about 3,000 binary RPMs, somewhere in that ballpark. As I said, many packages compiled fine without any modifications. Some needed extra patches contacting the developers. For example, Mono has had some strange source code issue where a macro wasn't defined or not properly tested so that it wouldn't build on the V9. But that has been sorted out. Other problems include very big toolkits. Java, for example, I didn't get compiled at all because at that time the OpenJ, it just didn't work. You know about thank you. What architecture for? ARM, I believe? Yeah, I hope that language dies. So currently I'm in the process of getting 12.2, the subproject known as base :build, with mostly with success. As I said, glibc and GCC currently fail, which is sort of bad. And now I have here the demo of the installed system that I have. So from the bootloader, it will read a small boot sector from the disk and so on. And then you get the CLO bootloader, which is not based on Lilo, it's just SPARC improved loader. And that then can load kernels of any size. So if you have a hard disk, you can boot the machine. It's not dead iron yet. I can boot from network if kernel and init.rd together are less than 10 megabytes, which is from? Yaboot has a limit of 26 megabytes, I believe, was in the source code. It still wasn't enough. I tried to raise the Yaboot limit to 64 megabytes, and this is CLO. Yes, it uses open firmware like Yaboot to download the image. The problem is, if I remember correctly, that the firmware only allocates a region of a handful of megabytes, 10 megabytes in case of SPARC. And if you need more, you probably need to install extra page tables or something in that kind. So I look forward to trying grub2, seeing if it can do that also on PVC. I could, but unfortunately, I'm not that versed in the low-level hardware programming yet. As you can see, I actually do openSUSE packages very much. So here's a check forced because I just resetted the machine before to do the demo, so we can't see anything on that yet. So the repository URL is there, and I also have a almost empty page on blackaris.de. That's the code name I chose for the small project. Okay, that doesn't work. And that would be so far the end. Are there any questions or contributions, donations? Yes, please.
My question would be, so you are running a private build service instance, if I understand?
Right, because the Nuremberg server doesn't have any of that hardware to run it.
Scheduler, yeah. So my question is, can we actually see the build failures for your architectures? So
yes, if
I mean, is it publicly visible, the build service instance?
Unfortunately not, because meanwhile I also have used this instance for projects of my employer, and the rights management of build service 2.1 wasn't yet there where I wanted it to be.
Okay.
But I can give out any logs, and the RPM packages are also up there.
Yeah. I'm just asking because sometimes for ARM it's quite interesting to see if it fails also on Power or on SPARC. So we often see a pattern and it helps often to find a problem. And maybe if it builds on Power, we know, okay, for example, Dinar has already found a problem and fixed it, and it's much easier to fix it than for another architecture as well, usually. So some kind of collaboration would be probably nice.
Yeah, I have worked together with David Miller, who's the maintainer of the SPARC kernel port, and he has been very helpful in dealing with some of the bugs. One, for example, was that SUSE defaults to bind now, which just wasn't implemented in the more recent glibc, and it was like, SUSE, what are you doing?
I see. Thanks.
It's that thing that's really pressing me all the time, and I'm still wondering the why. Do you want to revive your old hardware to actually run something useful on it, or is it more of a hobby project to learn how all that works?
It's a hobby to be a little exotic on architectures. So almost nobody has SPARC hardware lying around, and the SUSE SPARC port had languished since the last release, and so yeah.
So you're not using any SPARC hardware in production?
Well, I use this machine in production, so to speak. It's a build service for my employer as well.
Okay. Just asking because there are some people still using SPARC in space missions and stuff, so there actually is some use case for building on SPARC.
Yes, I think the space missions that you're talking about use a 32-bit Leon processor, which isn't targeted by any current distribution, simply because the hardware is virtually non-existent, and second, all the maintainers have stepped off the SPARC 32 kernel port, which is also because the old hardware, just like early 386s, had a lot of hardware problems, didn't have auto discovery of devices and so on.
Okay.
So I do tinkering with exotic architectures as well. I also have, I tried and I succeeded partway rebuilding the PPC part of openSUSE to do an experiment with this duality. Meanwhile, the PPC machine died.
We actually have full PPC build service support now, so you can do
yes,
everything.
but you don't ship the PPC 64 on the build service.
You can just build everything on the public build service on your own because all the machines are publicly usable now.
I know, but
so you can build your own repo on the public build service and just build whatever you like there.
Yes, but it's often congested. Sometimes.
Yeah, right.